Another excuse for the water in the Apollo samples is that it got there by the solar wind. That charged solar hydrogen atoms interacted with the oxygen in the lunar rocks to create water molecules and/or hydroxyl. As far as I can tell, the scientific community has rejected this theory in favour of the comet impact theory, which, as just demonstrated, has its own set of problems. But, for argument's sake, let's assume that it's true, that the solar wind can react with the lunar oxygen and create lunar water. Could it account for the water found in the Apollo samples? As we learned previously, the water detected in the lunar poles was as high as 0.3% by weight, or half of what was found in the Apollo samples. And indeed, just as Clark pointed out, the detected water content for the equatorial regions was so low that it is practically non-existent in this M3 data. The blue areas represent the water that has been detected. Given that the Apollo samples apparently have more water than even the rocks found in the polar regions, we should expect to see blue splotches in this representation of the M3 data. Instead, we see nothing but red and green, respectively representing iron-rich pyroxene and solar infrared reflecting off the lunar surface. Obviously, the water in the Apollo samples cannot be attributed to the solar wind. In summary, we find that the Apollo samples do indeed have water contents that are commensurate to their terrestrial cousins. We know that this water should have been vaporized as per the giant impact theory. And for reasons discussed previously, we know that this water did not come from comets or terrestrial contamination. And to top it off, the water contents in the Apollo samples exceed the maximum contents that one can get at the lunar poles, the only place where you can get water on the moon. As Taylor stated in Webb's Space.com article, the lunar geologists can't find the difference between the alleged lunar water and water on Earth because the oxygen isotopes in the moon rocks are virtually the same as their terrestrial cousins. Pretty much the same way, the chemistry of the Apollo samples is virtually the same as their terrestrial counterparts. But that's something I'll cover in the next episode. For now, this concludes my coverage of water in the moon rocks. Stay tuned for the next installment, where we'll look into their mineral composition.
Right. Right.